Okay, so here we go with the last lesson of 6.5, which is titled Solving Trigonometric Equations. And it's a really nice add-on from the lesson we did in 6.4. 6.4, you were learning, well, what answer does your calculator give when it solves these trig equations? And then now what we're going to do is look at all the answers you could get if you were solving these trig equations. So we're going to start with something like sine x is equal to a half. And to relate this, you'd be solving x is equal to the inverse sine of a half. And if you plugged it into your calculator, it would give you one answer. But we're going to look today for all the answers. So we're going to start off by drawing the sine x graph. So we're going to draw y equals sine x on this graph here. And you won't have to graph in this lesson. This one's purely just for understanding the answers we get. So if you're graphing sine, it starts at 0, 0. At pi by 2, it goes up to 1. At pi, it goes down to 0. At 3 pi by 2, it goes down to -1. And at 2 pi, it comes up to 0. And so it's going to look something like this. There we go. And then back up at 2 pi. And then we could extend this pattern to the other side. And it would look something like this. And I say something because it's really hard to graph on this screen. And lastly, at 2 pi, it would come back down to 0. So this is our sine x graph. This is y equals sine x. And we're looking where that y value is equal to a half. So I'm going to draw us a horizontal line at y is equal to a half. So if I go across and I say that this is y equals half, I'm looking for all the x values that give me this y value of a half. So I've got here, I've got here, I've got back here, and I've got over here. And I'm looking for what are those x values. Well, let's start off solving them between 0 and 2 pi, or between 0 and 360 degrees. So if I was trying to solve where does sine x equal a half, what I would start off with is my special triangle. So sine x, where does it equal a half? So if I draw my special triangle, I'm looking for it being positive, so I'm going to look in the first quadrant. This is giving me y over r, so the y is 1, the r is 2, which makes the x root 3. So this is my 1, 2, root 3 triangle. Across from the 1 is my smallest angle, which is my pi by 6. So even if I was doing this in degrees, it would still be my 1, 2, root 3 triangle, and this would be my smallest angle of 30 degrees. So one of the answers is pi by 6, or 30 degrees. To find the next answer, I have to find where else is sine positive. So I can use my cast rule, and I could say that sine is positive in the first quadrant and in the second quadrant. Because we've got this drawn up here, you can see that one of my answers is in the first quadrant, 0 to pi by 2, and my second answer is in the second quadrant between pi by 2 and pi. So to get that angle, you're going to do a reference angle of pi by 6, because this would still give me 1, 2, root 3. It's just that the root 3 would be negative, which doesn't affect sine. And I would get my next answer. So pi would be 6 pi by 6. So 6 pi by 6 minus pi by 6 would make my second answer 5 pi by 6. Or this is 180 degrees. If my reference angle was 30 degrees, then this angle in here would be 180 minus 30, which would be 150 degrees. So my two answers between 0 and 360 degrees is 30 and 150, or between 0 and 2 pi would be pi by 6 and 5 pi by 6. But what if I change the question? Instead, I want absolutely every answer between negative infinity to infinity. So that would include these two answers here. It would also include, if I continued this pattern on, it would be here and it would be here, and then it would continue on and on and on. So what I want you to notice is that these answers happen every cycle. Well, how long is a cycle for a sine graph? Well, it's 2 pi. So if I wanted my answers, I'd say the first one happens at pi by 6, and then it would happen the next cycle. And I'm going to put 2n pi because it could happen the next cycle to a positive direction, so I could add 2 pi and get these answers, or I could subtract 2 pi and get these answers. And then I could subtract 4 pi, or I could add 4 pi, and I would get next answers from there. So what I say is I'm going to add 2n pi, where n is an element of the integer system. So I could add positive 2 pi, or negative 2 pi, or positive 4 pi, or negative 4 pi. And then I want my other answer. So my other answer is my 5 pi by 6, and again, I'm just going to add 2n pi. Once you do this a few times, it just becomes rote because it's this every single time. If you were to do it in degrees, it'd be 30 degrees plus 360 degrees n, where n is an element of the integer system. My other answers I would get by taking 150 degrees and adding 360 degrees n, NEI. There's no shorter way of doing this. You have to do both answers and add a cycle because you can't get from 30 to 150 and then only get to the next cycle, which would be 390 from with both of them. I can't add what would be 150 plus 360, 510. I can't get to 510 from 30 without getting a whole bunch of other answers. So we just take both of our answers and we add a cycle. So how do you get these answers? Well, you're going to look at your cast, you're going to look at your reference angles and what quadrants they're in, and then you're just going to be adding the cycle onto it. All right, so the principles of regular equation solving are going to apply to trig equations. And remember, if you're solving anything that's quadratic, you have to equal 0 before you solve. And then you've got your 4 ways. You've got factoring, square root method, completing the square, quadratic formula, and so on and so forth. So how do we find all solutions? So this is when it says all solutions, it's meaning between negative infinity to positive infinity. And we're going to just at the beginning practice radians and degrees. So first thing we're going to do is basic equation solving. So we're going to isolate cos x. So we're going to subtract 1 and you get 2 cos x equals -1. Then you're going to divide by 2. And then we're going to solve this. So we're looking, where does cos x equal -1/2? If you want to do this extra step and write this, that's fine. But just make sure that you understand that you are not finding the answer in a restricted domain because you wrote the inverse cos. Only when the question is written as inverse cos do you give an answer in a restricted domain. So I'm going to leave mine just like this. So I'm going to draw this. Oh, I got to get out of eraser mode. I'm going to draw my reference angles by looking at cos being negative. So C, A, S, T. Cos is negative in quadrant 2 and 3. I want the x value to be -1. I want the r value to be 2, which is making this my 1, 2, √3 triangle. And my reference angle then would be pi by 3, or 60 degrees. So my two answers in one cycle is that x equals 2 pi by 3, or x equals, I have to think about this is, so I'm way better in radians. So you've got 3 pi by 3 minus the pi by 3, which gives you the first answer. Let's just do it in radians first, and then we'll do the degrees after because I can't switch my brain. And then my answer in the third quadrant in radians would be 3 pi by 3 plus pi by 3, which is 4 pi by 3. If I wanted to write these exact answers, but in degrees, this is 180 degrees, there we go. And then I'm subtracting the 60, so I'm getting 120 degrees. And then my answer in the third quadrant would be 180 plus 60, which would be 240 degrees. Then if I wanted the answers, all the answers from negative infinity to infinity, I literally just add 2n pi to my answers that are in radians, and then I go like this, so I don't have to write it twice, NEI. And then to these I add 360n, and then I put in my NEI. Awesome. All right, so I recommend pausing the video and you trying the next one, and then unpausing and hearing me talk through it and see if we get the same answer. So looking at this one, the first thing I'm going to do is isolate tan x. I'm going to subtract 4, which gives me -2. And then I'm going to divide by that 2, and I get -1. So then I'm looking for which answers are negative. So C, A, S, T. Tan is negative in quadrant 2 and quadrant 4. So I'm going to give these answers all positive. Again, we're not doing 6.4's lesson right now. So I'm looking for my opposite being 1, my adjacent being 1. So this is my 1, 1, root 2. So again, 1, 1, root 2. This is the negative, which makes it negative. But what I care about is my reference angle is pi by 4 or 45 degrees. Pi by 4 and 45 degrees. Now I want to find my two answers. So for the first one, x is going to be, so we're going to do it in radians first. So I'm looking at 4 pi by 4 minus pi by 4, which is 3 pi by 4. My second answer is in the fourth quadrant, so I'm looking at 8 pi by 4 minus pi by 4, which gives me 7 pi by 4. And then to both of these, I'm adding 2n pi. And for both of these, I'm doing NEI. Then I'm looking in degrees because I can't swap. So now I'm looking at this being 180. 180 minus 45 is 135 degrees. And then in quadrant 4, I'm looking at 360 degrees minus 45 degrees, which is 315 degrees. And to each of these, I'm going to add 360 degrees N, where NEI. It's really important that you write that NEI, because if you do not, then you are missing out on what N can be, and then it doesn't make it true. You'll notice if you're looking at the note key that there is an optional answer. So I'm treating this like it's any question, but in reality, this was tan. And so instead of having a cycle every 2n pi, I hope you know that tan actually has a cycle every n pi. And so for these ones, instead of adding 2n pi, you could have added n pi, or 180 degrees. Now tan, let's get my pen tool back, tan is a bit of a funny duck because if you think of its picture, it's that same cycle over and over again. It's this guy. And so this is happening every cycle. So when you're looking at this answer, I know it's supposed to be the negative one down here, it's happening every pi. In other words, if I added pi onto 3 pi by 4, I'm adding 4 pi by 4. Oh, I get that guy. So I don't actually need to do the whole thing. I just say for easiness sake, I would accept it as an answer if you just go, hey, this is rote, this is routine. Every single answer I add 2n pi and it works, and that's great. You will get every answer. They'll skip them. But for tan only, you're allowed to give just the first answer and add n pi. NEI. So in degrees, I could do 135 degrees plus 180 degrees and NEI. If you want to push yourself a little bit extension, please feel free to just give the one answer for tan because it happens every pi. In other words, from this answer here, if you add pi, you're getting to this answer here. If you don't and you just want to keep things really simplified and really the same all the time, take your two answers and add 2 and pi. It does work. It's just not a simplified answer. But most of your questions are going to say solve in a restricted domain. So they're going to say find an x value between 0 and 2 pi or 0 and 360 degrees. I'll only give one on a test. I won't make you do it in radians and degrees, but be prepared to be able to do both. One thing I want you to notice is that it always ends with a round bracket. And that's because if you think about your graph, so for example, sine, this point here is this point here. It's the start of a next cycle. So you always go up to here, but you include this one. Otherwise, you're kind of double doing yourself in two cycles. So what's different about these? It's a squared. So I said whenever you're solving a quadratic equation, make sure it's equal to 0, and then you can factor and solve. So you could either look at this as a difference of squares, and then you could factor it and solve, or you can solve using the square root method. So if I isolate my square, so I add 1 to each side, and then I take the square root of each side, then I can solve using the square root method. Just don't forget that it's plus minus. In other words, I'm looking where sine x is equal to plus or minus 1. So to solve this, hopefully you're kind of getting a little bit better at these ones. When we're looking at sine x, you have two choices. You're looking at where sine x equals 1. Now remember, sine follows y. So sine equals positive 1 at pi by 2. Sine equals negative 1 at negative 3 pi by 2. Or you can be looking at your graph and saying, okay, if my graph looked like this, at what point am I at 1? At pi by 2. At what point am I at -1? At 3 pi by 2. So my two answers in radians are pi by 2 and 3 pi by 2 in my restricted domain of 1 cycle. And if I was going to do this in degrees, it would be 90 degrees and 270 degrees. All right, try the next one. So for this one, we're looking at a squared again. This is again a question that can be solved using square root method. I wouldn't want to try a difference of squares. So when we look at this, although you could, when you look at this, you're going to isolate the cos squared x by adding 1 and dividing by 2. And then you're going to take the square root of both sides, make sure you go plus minus, and you're going to end up with cos x equals plus or minus the square root of 1, which is 1, over the square root of 2. So I'm looking where cos x equals positive and negative 1 over root 2. Well, if you think of cast, cosine is positive in the first and the fourth quadrant, and it's negative in the second and the third quadrant. So I'm looking for absolutely every answer. In other words, every answer with a same reference angle in each quadrant. So I'm looking for where the adjacent is 1 and the hypotenuse is 2, or the x is 1 and the radius is 2. So that's my 1, 1, root 2 triangle. So I'm looking at a reference angle of pi by 4 or 45 degrees. So in radians, my answers are pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. In degrees, my answers would be 45 degrees in the first quadrant, 135 degrees in the second quadrant, so 180 minus 45, and then 180 plus 45, so 225 degrees in the third quadrant, and then 360 minus 45, or 315 degrees in the fourth quadrant. All right, moving on. The next question is a one that you have to factor. So again, if you're not comfortable at this point factoring quadratics, please feel free to do the u substitution. In other words, make this 2u squared plus 3u minus 2, and then factor it this way. Or if you're okay with there being a cos in there, just go for it. So we're looking for a number that multiplies to give me -4 and adds to give me +3. So I'm splitting my middle term up into positive 4x, cos x, minus 1 cos x. So 4 minus 1 is 3. 4 times -1 is -4, minus 2. I'm going to factor by grouping. So I'm going to take out a 2 cos x to be left with cos x plus 2. I'm going to factor out a -1 to be left with cos x plus 2. I'm going to greatest common factor out the cos x plus 2 to be left with the 2 cos x minus 1 equals 0. And if I'd done the same thing with the u, I would have got to the same place. I would have got u plus 2 times 2u minus 1 equals 0. And then you would have had to know that the u was your cos x. So when you solve these, u equals -2, you'd replace the u with cos x equals -2. But I'm just going to keep going. I'm going to solve my factors. So the zero factor property, I'm going to say what makes cos x plus 2 equal to 0 when cos x equals -2, and what makes 2 cos x minus 1 equal to 0 when cos x equals 1/2. Okay, so now I'm solving both of these. The first one is, where does cos x equal -2? And hopefully you remember that -2 is out of that restriction. So it can only be between -1 and 1. If you think of a cosine graph, it only goes as high as 1, it only goes as low as -1. So there is no solutions. And then where does cos x equal positive 1/2? Well, CAST, cosine is positive in the first and the fourth quadrant. So I'm looking at my x being 1 and my hypotenuse, or my r, being 2. So this is my 1, 2, root 3 triangle. So my reference angle is pi by 3. So my two answers in radians are going to be, I'm just looking where I have space. My two answers in radians are going to be pi by 3, and then 6 pi by 3 minus pi by 3 is 5 pi by 3. My answers in degrees, this is a reference angle of 60 degrees, so my answers would be 60 degrees, and 360 minus 60, which is 300 degrees. All right, the last one on this page, and then we're going to take a little break for you to go and practice some of these. So again, we're going to solve for cos x. Now this one's going to come out a little weird. This is going to end up with cos x equals 2.0186 minus 3, which comes out to negative 0.9814, which is obviously not one of our special triangles. So what I want you to do is I want you to use your calculator to find the reference angle, because that's really all we're doing when we're drawing the triangles, is trying to find what's the reference angle so I can put my answer in the quadrants I want it to be in. So before we do that, I just want to think like we did with the other ones. Where would my answer be? Well, C, A, S, T. I get negative answers for cos in the second quadrant and in the third quadrant. So I want to know these two answers. I have two options. Option number one, you can plug in that x equals the inverse cos of negative 0.9814. And if you plug that into your calculator, let's just do it in degrees to start because they make more sense. So set up degrees. So I'm going to type in inverse cos of 0.9814 negative. And I get, does it say what it wants? We'll just do it to the nearest tenth of a degree if it doesn't say. So we get 168.9 degrees, which means this angle in here is 168.9 degrees. What's the downside of that? Well, the downside is I have no idea now how to get the answer in the third quadrant. So I have two choices. I could figure out what the reference angle is by doing 180 minus 168.9, and I would get that the reference angle is 11.1. And again, I'm not actually getting 11.1, I'm getting 11.06 dot, 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 and I'm keeping that. And then to find the x value in the third quadrant, I would do 180 plus the 11.06, and I would get positive 191.1 degrees. So my two answers would be 168.9 degrees and 191.9 degrees, or 191.1 degrees. Alternatively, if you didn't want to do it like this, what I want to show you is that when I'm using my calculator, I always find my reference angle. And I always find my reference angle by plugging in the positive ratio. In other words, if I take the inverse cos of positive 0.9814, it's going to give me that 11.06. So inverse cos of 0.9814, it always gives me my reference angle. So this is going to be 11.06. Then I can put that reference angle into the other quadrants. So you have to know how to draw the picture. You have to know where you want the two answers to be, but I always type it of the positive because then I get my reference angle right away. It's just personal preference. And then I say, okay, so x in quadrant 2 would be 180 minus the 11.06, which is my 168.9 degrees. And my x value in quadrant 3 is my 180 plus the 11.06, and I get the 191.1 degrees. Now, I find this is all well and good when we're talking degrees, but what we really want is radians as well. So all you do is you switch your calculator to radians, you plug in the inverse cos of 0.9814, and you get your reference angle. So switch your calculator to radians, and then I do inverse cos of 0.9814. And it gives me 0.1931 dot, dot, dot. This is my reference angle. Now I'd want to find x in quadrant 2, and I would do pi plus the 0.1931. So I would store this answer as A so that I can use it again. And then I type pi plus recall A, or whatever you choose to do, and I get 3.3 radians. And then I do the same thing in quadrant 3, but I do, oh, sorry, that one was quadrant 3. So sorry, quadrant 2, sorry, should have been pi minus 0.1931. So then I do it again. I go pi minus recall A, which gives me 2.9 radians. So quadrant 2, you do pi minus. Quadrant 3, you do pi plus, but you get your answers in radians. All right, hopefully that makes sense. I recommend you try these questions before moving on. The next lesson, just to give you a heads up, we're going to be doing a little bit more of the factoring to solve, but then we're going to be involving some trig identities with the solving as well. So practice ones that don't look weird, so they can't have like a cos 2x or a sine 2x. Hopefully they don't have any major glaring things that make them tricky. Otherwise, watch the next lesson first. But see if you can practice a few of the questions in the textbook, like the easy ones, and for this stuff, and then we'll come back and finish the lesson.